surrounds the gut tube. So let's do that. And in order to make it work, we are going to have to squish it up a little bit. So bear with me while we start folding all of this into one tube that zips together anteriorly. And the zipping together anteriorly is what completes the entire gut tube, lined by endoderm in yellow, and in red the supporting structures that are going to supply it. So connective tissue, smooth muscle, all the vessels that are going to supply that area, and eventually this peels off so much that it's only left connected to the body wall by a thin strip of mesoderm called a mesentery. So we're going to fold this in and out of the way just a bit. Sorry, it gets a little ugly. Better idea. So that we're left with the gut tube hanging out ventral to the notochord. And now the same process is going to happen with this layer that's in contact with the ectoderm. This layer is called the somatic or parietal lateral plate mesoderm, and it is going to fold anteriorly just like the visceral layer did. But as it does so, it's going to get longer, and it's going to wrap all the way around and surround not only the gut tube but make a cavity within the body. To make that happen, let's squish it out just a little bit. Give ourselves a little more room to work, because the body is actually dividing considerably and getting much larger as this process takes place. And this little manta ray looking thing is going to approach ventrally, surrounding the gut tube, and form the anterior body wall right there. And that zipping together is what forms the thoracic body, the thoracic cage, the abdominal body wall, and most of the pelvis anteriorly. So that's how we wind up with a human body that's a series of tubes. We've got the neural tube, the gut tube, and if you want to think of the somatic body as a tube, you wouldn't be far wrong. And from here on out, development proceeds more or less with the embryo looking sort of like a human being, and organs get larger and develop, and we'll cover those another time, another place. All right. So one thing that we've neglected to do earlier is talk about what's happening with the amniotic cavity this whole time. You may remember we cut the lid off the top of the amniotic cavity so that we could demonstrate how the epiblast undergoes gastrulation, neurulation, we produce the trilaminar embryo, and then eventually fold the whole body wall together to create pretty much what an early fetus looks like. In this process, we forgot about the embryo, and we're going to remedy that now. So right here, Matt will be our embryo. If he takes a quick turn around, this will be ectoderm on the back in blue. He turns back around, and Sarah will give him his gut tube hanging up in front, right there. So gut tube in front, ectoderm behind. We'll take that back for a moment. As Matt spreads his arms to the side, this is going to be that long stretch of somatic lateral plate mesoderm that folds around to the front. Think about this extending all the way down like a cape, and as he folds his arms together towards the front, it joins anteriorly, sealing up the body wall. And remember, the gut tube, good job not hitting him, is hanging out inside, and it's totally surrounded by the somatic lateral plate mesoderm. And this space that's created between those two is going to be what makes up the respiratory cavity, the abdominal cavity, and even the pericardium. And early on, this is known as the intra or intraembryonic coelom. Thank you very much. You can pull that out. Now, because the amnion is attached to the top of the somatic layer of mesoderm, you'll take that side, around here. Matt's going to extend his arms back out. He's going to grab each side of the sleeping bag. But I want you to think about, we've put the amnion back in place. This is the lining of the amnion, and the space between his back and the sleeping bag is the amniotic cavity. As the somatic layer of lateral plate mesoderm folds forward, seals up, it brings the amnion with it. So this space completely surrounds the embryo, and if we hold this here, his hands eventually completely disassociate from the amnion, form a complete anterior body wall, and the amnion is just completely covering the developing embryo, much like a sleeping bag would somebody sleeping inside of it. So the amnion comes along for the ride but maintains its position around the embryo up until birth, when it ruptures as the baby comes out the birth canal. Thank you very much. And thank you, Matt and Sarah.